Hello everyone, welcome back. This is Naidu from Techno Legal Forum. We'll continue our discussion from last session. We were discussing about hashing concepts, how exactly hashing works. In today's class and the last class on hashing, we are going to know about applications where exactly hashing is used. Okay. Let me clear the okay. Remember always this CIA triad, security triad, or you can represent like this CIA. Like once again, CIA stands for confidentiality, which we achieve through encryption, which we already studied. I stands for integrity, which we achieve through hashing. A stands for availability of data, that we are going to discuss in our future sessions. Okay. First application of hashing, password storage. Okay. Let's let you take me to the whiteboard. Remember, when you log into website, let's say from the system, you are providing username and password. When you in the website, a login page, many times you receive a login page, right, for authentication. When you provide the site password in that login text field, technologies have improved. Basically the hashing, which we are discussing now, instead of password traveling to the, let's say this is server, where database, where password earlier we used to say passwords are there. Instead of that, we save hashes. So when a user provides a password, instead of sending a password, we are sending a hash of that password. Remember how you generate a hash? Using a hash function. The input is password, output is 64 character hexadecimal fixed length output. So this hash travel here. Here also the hashes of the password, suppose P1 password 1 hash is this. Here also we don't store the password. Instead of P1, this is server, this hash is traveling across the net, it has to get authenticated in the server. Server is one part of the corporate network. For this user to access the resources in the server, the first step, remember, is authentication. So the hashes will travel here. Here also hashes are stored instead of password. Remember, passwords, giving passwords is a very unsecure method, right? You never want to have your secrecy. You want to suppose if I have to say you want to give secret of your bank locker, right, a Swiss account. You don't like to give it, right? Even Swiss bank, let's say, authority which you are giving, even authority is so trusted. When there is a hashing technology that we can use, why you just use the hashing, right? You can use the hashing which represents the password. So coming back, the hash will travel all the way here. And it gets matching will happen. This hash is verified in this database. If this hash is found in the database, user is allowed to authenticate. So there is no password traveling over the network. It's a very highly secure way of logging through it. So the website converts the password as you type in into a hash. Hash travels already. The the server always contains the hashes of the password ahead of time. So the comparison will happen. If the hash matches with the one is there in the database, it means that the right user is logging. Okay, this is one of the application. Isn't it very fantastic? You are here totally, we are avoiding giving password, right? That is something very very important. Now let's go back to the other application. File integrity check, download verification, Ubuntu Linux. See, Linux is a freeware, right? Some distributions of Linux are freeware operating system. Linux operating system. People download it and start using it, right? Let's go back to the whiteboard. You go to the Linux, Ubuntu, so for example, Ubuntu website, and you find download of that software. Across the software, they tend to provide the hash of this 64 character, unique character, fixed length of this entire software is represented by 64 character. Remember, hashing function is one way. You can generate a hash. You cannot using hash you cannot get this software. It is something like I provide a fingerprint. Using fingerprint you cannot generate a human, right? It's as simple as it is. So it's a one way. Hashing function is one way. Unlike encryption, we encrypt useful information into unreadable characters. We call it as a ciphertext using a secret key, and at the receiving end we use this unreadable information for the whole world. At the receiving end of the intended person, the same secret key which used for encrypting is used to decrypt, and the intended person alone can read it. So it's a two-way function. Whereas hashing is a one-way function. You can only convert into 64 characters. That's why it's more about, it's not the, in CIA, high integrity data, it is only performing the data integrity. If there is a manipulation of even a single punctuation mark from the source to destination, a document traveling from source to destination, even if it on the way for whatever reasons, even a single dot is added to the original document, the hash, another unique hash gets generated. Then it means that the document is modified. Okay, so it is purely checking integrity of the document in the CI model. Okay, so see, one advantage I'll tell you, if you download, suppose you have a software, any software, not only Ubuntu, any freeware software. Freeware softwares from the authentic websites will have 64 character hexa. There is a hash which is created out of that entire software. Remember, the hash function can produce, it takes even 2 character, but still it produces 64 size character, fixed size hash string of character, 64 width. It takes 5 GB, biggest, let's say 5 GB is very huge, right? Even it takes 5 GB, yet it creates again same size. Okay, that's the uniqueness of this. Now coming back, even viruses, malware and what you call malicious software or virus can also be detected. Suppose this is the genuine freeware software. Freeware, some gaming software, but from authenticate from a genuine website. You pay, subscribe and try to you download it, and this software also has a equivalent hash generated by the developer. You download the software into your system. Okay, then your system has a capability to generate hash of what you downloaded. You download it, right? Software, what you download, hash. So this published by the developer H1. You download the software, then use your computer to generate hash of it, and you get H2. If H1 is equal to H2, same 64 character matching, then the software which you downloaded across the internet is not modified. Let's say that is standard scenario. Suppose if this software which you are downloading, because downloading is not from one system to one system, right? It goes through various intermediaries across the internet. If this software gets infected by a virus or malware, we say malware is nothing but malicious software, malicious or a virus, by an hacker. It infects it in between. You download it, but you know already the published hash here. Remember, published hash you already have in the genuine website. You generate. So when something get infected, it means the software got an addition, something got added, or something got deleted, or something got modified. All these things are changes. Remember, hash function, even if it observes a single dot, it will end up in generating a unique 64 character hexadecimal string. Correct? Same input, same hash. Even a small difference in the input, output will be different. So when you say infected, what is infection means? The software delete something, the malicious software deletes something of the original software, or it adds something, or it won't delete or add, it will only change the code. These are all changes immediately caught by the hashing function, and it generates a hash equivalent to that. It won't fix anything, it's not an antivirus, it generates a hash for it. Obviously this hash will be different, and the published hash is this one. So h1 will not match with h2, then the user will gets alerted and he becomes aware it has been infected or it's modified, and he might delete it, right? So that is a second function. See, this simple hash function is serving so much, the piracy. Piracy is like movies in Netflix or in any movies. Somebody else creates another Netflix with same software and creates same software, same user interface, website, and obviously you will not able to generate that exact hash of the original movie hash code. Okay, so this completely prevents data manipulation, or the very important, again I'm repeating, CI tried security. See, as I earlier said, CI of an organization, if the organization has a very excellent CIA, it increases its credibility. Credibility increases means its reputation increases. Credibility plus reputation means companies will trust it. When the companies trust, they will give business. When they give business, revenue of that company increases. Revenue, profits, intellectual property, and it grows. So every organization must strive for CIA. How organization CIA is excellent, moderate, or excellent, who will decide? Third party will decide. How they will do? They will conduct an audit. So audit, for example, SOC 2. We will talk about these things later, but these are the industry standards, SOC 2 audit, we say. So they will, third party will come and check all this, how the data confidentiality of the customers maintained by X organization, how integrity is maintained by that organization, how availability of data is maintained. So once they certify, this will improve reputation of that company. Okay, so now we have dealt with password storage, file integrity, that is downloading freeware or Linux, any software, by verifying this thing. Third is Git. Git is a version control system. Many of you already know, but for the sake of those who are hearing about what is Git, I will just briefly explain. It is for tracking changes in the source code, collaborate with teams, maintain complete history of project. Very quickly, let me go to the what I'm doing. So any software, suppose if a software company is there, let's say 40 members are there for development of an application. All of these 40 members divided into multiple small teams, each will work on different components of the user interface, features, other things, right? Everyone is working on single software. How do we ensure that all their work is maintained, updated, everything? So Git is one which, so what exactly it means that everyone working piece of documents, whenever he commits, that piece of work what he has completed will get a unique number. Is nothing but is running a hash on this work which he has completed. It get generated a unique 64 unique hash. Let's forget hash. Again he does changes. One day he won't develop, right? He will do changes. Then again he saves, then generates hash H1, H2, H3, like that. So one person does like that, multiple people done. So everyone is doing, right? All different versions. How we identify versions? By unique hashes. All this keep updating in those files, and using the commands they upload into central location. We call it GitHub. That center is a cloud based, let's say. So the cloud, if it's cloud based, then everybody can access from anywhere, right? So all this get it. So this way of updating and managing the entire servers. Finally, when everyone is have a final version, remaining old versions they will delete, and final versions of each piece of them are merged to make an application. So it's a collaborative tool available for several developers for the source code development and versioning. Different versions they create, history they will have, what changes they have done, everything use the git commands, and they keep uploading to the hub and downloading to their desktops, again working. Once work is finished, again they will update. Simultaneously everyone is doing, but due to this technology of hashing what we are discussing so far, we will ensure that every file is has a unique hash number that makes it to understand that if the file is unique or not, right? By you have version control, based on that you should be able to do which one need to be merged to get the final application. So that is one of the, I hope this clears. Git. So the last one is deduplication in cloud storage. Dropbox, iCloud. It's very simple. Suppose if you are in the cloud, I represent like this. You have a storage. Remember, you keep uploading files, photos, files, documents. So if it's a freeware, it's a free subscription. For example, Google. If you have Google account, I think you get 1 GB free. If you get more, then you have to pay, right? So hundreds, thousands of people have 1 GB. Or let's say this is 10 GB used by 10 people in a family, let's say. Everyone keep watching mobile and something interesting they keep uploading, right? Uploading to their one folder, family folder. Everyone is uploading. Suppose I watch the same video, 2 days later another member in family watches another same video again. He also want to save it. This one already saved it, right? So immediately space will get over because so many files getting uploaded. So in order to avoid that, hashing again helps. How? Same file, same hash, right? Same file, same hash. If another person is uploading same file, it will also have same hash. The moment it finds same hash, it will delete, or it will not allow same file to be uploaded. Thereby you have only one file uploaded. What is ultimate objective? Space optimization. Unnecessary waste of space, storage space is eliminated. Understood? Okay. So that completes 4 applications of hashing. Okay, so we will end at this point, and we'll jump to various authentication protocols, starting with the earlier versions and what is currently being used in the enterprise environment that we are going to discuss in our coming class. Till then, have good rest of the day. See you then. Bye.